Okay, in this video, I'm going to show you how to use the geoprocessing tools provided by QGIS to digitize Riverscape features in QRiS. If you haven't watched it already, Josh has made an excellent video going over the digitizing toolbar and also the advanced digitizing toolset, which I would recommend watching before this video. This is an alternate way to digitize Riverscape features, especially when you're dealing with a long Riverscape to digitize over. This can save you a lot of time in the digitizing process. So shown here is an orthomosaic of the middle 30-mile reach of 30 Mile Creek, and it's about a couple miles long. For time purposes, I'm just going to do a subsection of the orthomosaic, but it will highlight how these geoprocessing tools can facilitate the digitization process and save you time. So we'll zoom into here, and for this example, I'm going to be using a few of the data capture event layers: vegetation extents, inundation extents, active channel extents, and active channel lines. These geoprocessing tools can be used for other QRiS layers, but for this video, I'll just be using this example. So to start out with, I've already gotten my valley bottom, and I'm going to first begin by digitizing the active channel. So we'll get to a resolution where we can see the channel and digitize it accurately. And so I'm just going to be digitizing the center line of the primary channel first before digitizing the secondary channels. This will not be perfect, but okay. So now we have our primary channel. Now I'm going to turn on snapping and then digitize these secondary channels or non-primary channels. And I think there's just one more roughly about here, I guess, if you wanted to call it that. Okay, now we'll save. Now what we want to do is convert the active channel lines into the active channel extent. And to do this, we're going to be using the buffer tool. But before doing so, all QRiS layers are in WGS84, and therefore they're not in a projected coordinate system. And so if we do try to run that buffer tool, we can see that we're only get it into degrees, and we need it in meters. So you can just go to your data management tools, go to reproject layer, and then we'll change that to a UTM coordinate system so that it is projected. You will run. And now we can buffer those active channel lines by unit measurements. So we'll be using meters here. But before we do that, I'm going to take a few spot checks to see what our average channel width is approximately. So we go there, that's about 4 meters. That seems to be about 5 meters. There's about 3 meters. Down here is probably like about 3 meters as well. And so let's just say 3 meters is our approximate channel width. We will then go to buffer, and we're going to put 1.5 meters. Since this buffer is running on the center line of the active channel, we'll have 1.5 meters on either side, which will total up to 3 meters total. And then we're also going to select the dissolve result option and hit run, which will create this temporary layer with that 3-meter buffer. We'll change the symbology so that there's no fill. And then now we will turn on our editing and then select the reshape features tool. And so now we can just go down and also turn off snapping, my bad. So now we can reshape the channel where either the buffer doesn't extend to the full channel extent. So like right here, we can just click inside the channel or inside the polygon anywhere. And then we'll digitize to that channel extent. And then right click to end or reshape, which extends it outwards. Or if the buffer has some vegetation in it, like here, we can click outside of the polygon and then end it on the outside of the polygon, right click, and we can now just, all we have to do is reshape. Since we did a rough average of the channel width, this can save a lot of time, so we only need to worry about the areas that we see channel areas that are noticeably should be in the channel or not in the channel. So there's a few areas, maybe right there like that. Maybe move that down a little bit. And then the rest of it is pretty good. It's not going to be perfect, but it's a good approximation of the channel. So once we're satisfied with that, we can go to the active channel extents. We'll right click, we'll import from a temporary layer. We'll make sure that buffer layer is turned on and visible, and then hit OK. And we don't need to save any of these fields for now, so we can just ignore them and hit OK. We can delete our temporary layers, and now we have the active channel digitized for this section. Next, we are going to digitize the riparian vegetation. And so I'm going to create a temporary layer of the vegetation extents to treat as sort of my working copy before I import into QRiS. I will change the symbology to have no fill and just an outline. We'll turn on editing, and now I'm going to select the add polygon feature and digitize the riparian vegetation, which we'll assume is this. And so you'll notice that I started in the channel, and I'll show you why I have done that shortly, but we will sort of digitize this little sort of vegetation buffer right by the channel. And if it doesn't extend on one side of the channel, so right here it butts up against these this rock right here, we'll just keep it inside the channel, only where we see vegetation. And then we will extend it outside of the valley bottom, which I'll show, and also show why I'm doing that in a little bit. We have some vegetation there. we'll right click the end and then just hit OK, since this is only going to be the riparian vegetation. And now we are going to use the difference tool to first clip, or first we're going to use the clip tool, my bad, to clip the vegetation to inside the valley bottom. And so the reason that I added the area outside is so that we can make sure that we are not losing any data. And so once we clip it, it will clip to the boundary of the valley bottom. And then after that, we are going to difference it from the active channel so that the active channel is not included in this polygon. And that's why I put, if there wasn't vegetation on one side of the bank, I put the polygon extent inside the channel because that will difference out so that it abuts nicely to the edge of the active channel polygon. So we will select that temporary layer and we're going to clip it to the valley bottom first, and we'll just hit run. So now we can see it abuts perfectly with the outer edge of the valley bottom polygon. Then we're going to select that clipped temporary layer and then difference it from the active channel extent. So we turn those off. Now we can see that our vegetation is clipped to the outer extent of the valley bottom and it does not include the active channel. Then finally, I'm going to also just dissolve it so that, so right now if you selected this, this is going to, it's a multi-part polygon, so it's just one feature with multiple geometries. And to clean it up, I'm going to just dissolve it so that we have one feature associated, or one geometry associated with one feature. So we'll dissolve it, we'll select the Keep Disjoint Feature Separate option and hit Run. So now these polygons are kept separate from each other. Now we will go right-click on the Vegetation Extents in the QRiS plugin. We'll import from a temporary layer. We'll make sure the dissolved layer, which is the one we want, is turned on, and we'll hit OK. We will turn off all the fields to be retained, and we're just going to change the map values for, since right now it's all blank, we could just change any of these to riparian, and then we'll hit OK. And therefore, if we turn that off, now all of that is now imported and shown as riparian vegetation. If you wanted to name it differently, so for example, if you had also non-riparian vegetation, you just go in here, select any of these fields, for example, and then just type in like riparian or non-riparian, and then once you use that widget to import from a temporary layer, you'll just make sure that it aligns to whatever your naming classification is for that temporary layer. So we'll just remove those temporary layers for now. We don't need them anymore. To do the inundation extents, which is the classification of flow of the active channel, we can select the active channel extent and buffer it by 0 so that we just keep we have the same polygon matching the extent of the active channel, and we now have it as a temporary layer. Now then we can turn on our editing and start splitting the features. So what I'm doing is not going to be in line with the version 2 protocol, but it's just here to show you an example. So for example, if we wanted to say this was ponding, we'll click and then we'll right click to edit and we'll split that feature there and there. So we have this ponding segment. We could also maybe call this ponding down here. And we'll just say this is an overflow. So right now, since this is a dissolved polygon, if you do something like that, it will give you an error. To remedy that, you'll just get as close as you can, and then you'll just run down this extent to there. And now we have that side channel. So I'm going to select these features. And in the notes, I'm just going to call it pond for now as a placeholder. If we select this one now, we'll call that overflow. And then the rest we're going to call as free flowing. So we'll change that to notes, and we'll call this free flow, something like that. These are just placeholder values. These are just placeholder values for the import widget in QRiS. So if we go to the inundation extents layer under hydraulic mapping, we will right click. We'll import from a temporary layer. We'll make sure that buffered is turned on. We will turn everything off here, but in notes, we're going to select map output, and we're going to hit add. So we have those placeholder values, and we're just going to align them to what is in QRiS. Hit OK. And now we have our inundation extents done. Finally, we have active extents. This is not going to be the case all the time, but what active extents are is just the active channel plus the active floodplain. In a lot of cases, your riparian vegetation is going to be a proxy for your active floodplain. So we'll use that for this example. And so what we'll first do is we're going to merge the active channel with the vegetation extent. So we have that active channel, and like I said, for this example, we're treating the riparian vegetation as a proxy for the active floodplain. And we'll hit OK. And we'll run. And so for now, we see that those layers are merged. We are going to dissolve, and we'll keep the disjoint feature separate for now. It should only have one feature, but if you were to do this for a couple miles of Riverscape, you probably want to keep those disjoint features separate and hit run. And showed nothing in there, which means I must have ran the tool wrong. Okay, I just ran the tool incorrectly for the wrong layer. And so now we have this polygon, which includes the active channel plus the riparian vegetation. And then we can just go to active extents. We'll import from a temporary layer. We'll do dissolved. And we'll turn all of these off. And so we can select any of these just because we have nothing named for it. It's all going to be active. So we'll do that and hit OK. We will turn those off. And now if we turn some of these layers off, we can see now we have our active extents. To get our inactive extents, we're going to just simply difference the valley bottom extent by the active extents. So we'll do difference. We'll have our input as the active. Our overlay will be the valley bottom, and we'll hit OK, which showed nothing, and that's because I accidentally did the reverse order. So we need the valley bottom as the input layer, the overlay as the active extents. Hit OK. So now we have the difference between the valley bottom extent and the active extent to give us our inactive extents. And then we'll do as before, we'll just simply dissolve it and keep those disjoint features separate so that they're not multi-part features. And then we'll import from the temporary layer. We'll select that dissolved temporary layer, and we'll turn all these off and then just call this inactive and hit OK. And there you go. So just for a quick recap, we just took some of the layers of a data capture event and used those geoprocessing tools to facilitate the digitization process. And like I said, this is probably roughly a quarter of a mile of Riverscape that we've done in probably roughly 20 minutes or so, maybe a little less. So before, if you use like traditional digitizing methods, this might take maybe double or triple as long. So like I said, especially when you're dealing with these very long riverscapes, you could save a lot of time using these geoprocessing tools. And so really all I did was I just delineated the active channel lines and the vegetation extents, but everything else was done using those geoprocessing tools and temporary layers. So thanks for watching.